Hello everyone, welcome to my video on impulse and momentum. In this video we will discuss what momentum is and we'll relate it to impulse. We will also take a look at graphs and functions. So, to start off, what is momentum? Momentum is a vector quantity, and it describes how difficult it is to move an object, and for angular momentum, it would be how difficult it is to rotate that object. So, if you're given a system and you wanted to find the total momentum, what you would do is you would sum up the momentum of, let's say we have like an object moving in this direction and an object moving in this direction. The total momentum would be the sum of the masses times velocities, and just keep in mind that a velocity is a vector. So if these two objects had the same mass and opposite velocities, the total momentum would be 0. Now let's relate this to force, and from there we'll find what impulse is. So from Newton's second law, we know that force is equal to mass times acceleration. And what we can do is we can turn this mass times acceleration into mass times dv dt. Because we know that acceleration is equal to change in velocity over the change in time. And because the mass is constant, and we know that the momentum is equal to mass times velocity, this would therefore, this portion right here would therefore be dp. So it would be dp dt. So now we've established that if there's a force on an object, we can describe it as the object's change in momentum over the change in time. So let's say that there was a given function and it relates the momentum of an object to time. And let's say that p of t is equal to, let's say it's 1/3 kt cubed. And you're given the information that there is a force that causes this momentum, and you're asked what is this force, and from this relationship above, we know that force is the derivative of momentum with respect to time. So we can rewrite the equation on the bottom as F is equal to dp dt, and so all we have to do is to take the derivative, and the derivative of this is equal to kt squared. So this is what the force is equal to. Now let's move on to impulse. So we can start with what we derived above. Force is equal to dp dt. Now we can multiply both sides by dt, and we get force dt equals dp. Now let's integrate both sides, and we have the integral, and this would be from, if we were to do this as a function of t, we would integrate it from 0 to t. So from 0 to t. And in n, what you would get is this becomes j, which is the impulse, change in momentum, is equal to the force times the amount of time that has passed. We could basically write this as F delta t. So this is what impulse is. The change of momentum, which is equal to force times time. Now let's take a look at graphs. So from kinematics, if we have a graph of time and velocity, we know that the total distance, the displacement is the area. The displacement is the area under this graph, because velocity times time is equal to distance. So displacement, I mean. So in this case, if we are given a force versus time graph, if we wanted to find the momentum, if we wanted to find the change in momentum, which is the impulse, all we have to do is find the area under this force times time graph. Now let's move on to collisions. So if we have, whenever we have two objects that collide, there will be an initial state and a final state. In the initial state, it may look something like this, and in the final state, let's call this object 1 and object 2. The final state could look something like that. But the thing to keep in mind is, no matter what type of collision it is, the momentum is always conserved. There will be no change of momentum as long as there are no external forces. Now there are two different types of collisions. The first type of collision is inelastic collision. And so what that means is that momentum and energy and kinetic energy are conserved. And the second type of collision is a inelastic collision. And on most of the AP problems, you can assume that it is completely inelastic. And what that means is if you have one object that collides into another object, they will move together at the same velocity in m. So momentum conserved, but the kinetic energy is not conserved. So for completely inelastic collisions, it's actually easier to solve for the final velocity of an object. Let's do an example. And we'll do everything in terms of variables. So let's say we have an object of mass m1, and it's going at velocity v1 into an object of mass m2 with velocity, let's say it's not moving, and it's completely inelastic. What this means is, here let's do the initial and final states. So initially we have the momentum is equal to m1 v1 and m2 v2, but v2 is 0. But in n, we know that after an elastic collision, both objects will move at the same final velocity. So we can say that it's equal to m1 v final plus m2 v final. So we can easily solve for v final. V final is equal to m1 v1 over m1 plus m2. But so this is for a inelastic collision. But now let's look at an elastic collision. The objects won't necessarily move with the same velocity in n. They could bounce off of, like for example, in this case, the first object in n could move with a slightly less velocity, and the second object will move at a different final velocity. In this case, you'll have to do conservation of energy, and you will also have to do conservation of momentum, and you can set up a system of equations, and then you can solve for the individual final velocities. But there is a faster way to do it, and there is an equation called the Chase equation, and this is derived from conservation of kinetic energy. And the equation is V1 initial plus V1 final is equal to V2 initial plus V2 final. These are vectors, so if you define left to be negative, and your V1 final was negative, then it would be it'd be like V1 minus 4 meters per second, something like that. But these are vectors. And then what you would do after you have this equation is you would also do conservation of energy, so mv1 plus mv2 equals mv1 final plus mv2 final. And let's just call this m1 and m2. The derivation for this part is a little bit long, so I will put that in the description. I will put a link to the derivation in the description below. And if you want to make this a little more, even more simple, but this only works for a special case for elastic collisions where the target is initially at rest, you can remember that the final velocity is equal to m1 minus m2 over m1 plus m2 times v, and the final velocity for the second mass is equal to m1 over m1 plus m2. And so this works when the target is initially at rest. Like this is the target right here. If this is at rest, we can use these equations. So it's a little bit of extra memorization, but it can save you some time on the AP test. Now let's just take a look at a practice problem, a real simple one. In this problem, we have a cannon sitting on a cart, and it fires. Well, initially, it has a mass m, and the ball has a mass little m, and the cart is moving at a velocity v. In the end, the ball is fired out, and it's going at a velocity vb. And what you're asked is, you're asked to find the final velocity of the cart. So this is really just a simple conservation of momentum, because we know it doesn't change as long as there are no external forces. So in the beginning, the only momentum, and remember m is the total mass, the mass of the cart and the mass of the ball. So mv is equal to, and in the end you have the little ball, you have the little cannonball moving at velocity vb, and you also have a cart, but now the cart has less mass. Now it has mass m minus mb. Yeah, we'll just call this mb. So the velocity of the cart is v times big M minus mb. And now it's very simple to solve for the final velocity of the cart. The final velocity of the cart is just equal to mv minus mvb all over m minus mb. So in these types of problems, just apply conservation of momentum, and you can solve for whatever you're looking for. So this pretty much wraps up my video, and I've also posted another link, and in it you'll find some practice problems for momentum on the AP test.